Hey everyone, it's that Math Magician. On this video, we're going to look at systems of equations and we're going to see how we can use the equal values method to help us solve a system. We want to see where two lines intersect. We want to know what that point is, and we're going to use this method here to solve for that point. So let's jump right into this problem where I have two equations, x equals negative 5y plus 2 and x equals 3y minus 2. And you might be thinking, whoa, these are not written in y equals mx plus b form, right? We're used to mx plus b. These two equations are not written that way. But we can still use the equal values method to solve this because of the fact that both equations are equal to the same variable. Notice that we have x equals negative 5y plus 2 and then x equals 3y minus 2, right? Both of those blue expressions there equal x. And since they both equal x, then that means that they must equal each other. That's what equality is. They both equal the same thing, then they must be equal to one another. So that means we can actually solve this out by writing out negative 5y plus 2 equals 3y minus 2. I know that they're equal because they both equal x. And now I just got to solve that equation over there for y. Let's isolate our y variable. I think what I'm going to do first is I'm going to take this 3y over here and I'm going to subtract it over to the left side there. Doing that to kind of group up my y variables. Well, look what happens over here. Negative 5y's take away 3 more. Well, that's going to give us negative 8y's. Still have the plus 2. Those 3y's there zeroed out. And I still have my minus 2 on the right side. Now, since I moved my variable over from that left side over to the, from the right side over to the left side, we got to move our positive 2 over to that right side. We want to move our constant over. So if I added 2 here, then I'm going to need to subtract 2 on both sides. Those are going to zero out on the left side. That's what we want. It's going to equal negative 8y, and that will equal negative 2 minus 2. That gives us negative 4. So we almost have our y term done. Our last step is to get y by itself. I have negative 8y's. I don't want negative 8. I want 1. So we're going to divide both sides by negative 8. Those negative 8's on the left side, they cancel out. We're left with just y, and it equals negative 4 divided by negative 8. Well, I think that those negatives are going to cancel out, so now it'll be positive. And 4 over 8 is the same thing as 1/2 or 0.5. So we have our y term. Remember, we're trying to find the point of intersection, right, where these two lines intersect. And I now know that that y term is 1/2 or 0.5. I like to use fractions, right? Fractions, they're your friends. So I know the y term. Notice I wrote it in the y spot. I did not write it in the x spot. But now I have to find the x term. But I have two equations there to choose from. You get to pick. I always say let's pick the simplest equation to use. I think that would be the second equation. It has one less negative on the y term. I think that'll help us out. So I'm going to use 3y minus 2, but I know what my y equals. We just found out what y equals. Y equals 1/2. So I'm going to plug in the 1/2 for x, and now I just got to solve this out. Well, let's see. 3 times 1/2, that'll be 3/2. We could leave that as a fraction. Might make more sense now to put it as a decimal just to make a little more sense with us. But 3 times 1/2 would be the same thing as 1.5 minus 2. Get a calculator out if you struggle with that. But 1.5 minus 2 will actually end up with an answer of negative 0.5, which is also the same thing as negative 1/2. That is the x term for our point of intersection for those two lines. And we did it using equal values method. We can use it because they both equal the same variable. It's that Math Magician, and I'll see you on the next video.